Okay, lesson 54. Now, we're starting off talking about velocity and acceleration. In calculus terms, we've already mentioned velocity and acceleration this year, yes? Do you remember the connection?
Derivative of velocity is acceleration.
Okay, derivative of velocity is acceleration. And you get velocity by doing the derivative of the, what they call position function. Okay? So, and they call it, there's another name that they use for it at some points. Besides position function, I can't remember what it is. But yeah, the idea of if you start with the position function, the derivative of position is velocity, and the derivative of velocity is acceleration. Okay, so notice, okay, right here, start with position function. So on today, they use x of t. Sometimes you'll see s of t. And notice, when we talk about position, your units are just regular units, such as feet, meters, inches, whatever we're talking about here. Okay? We kind of already know this from before. The derivative of position is velocity. When you do velocity, when you do that derivative, so it's the change in position with respect to time. And so you'll notice that the units is something such as feet per minute. Okay? Because again, derivative is change of position with respect to time. And then the derivative of velocity is acceleration. And so when you do acceleration, you're doing the derivative of velocity, which is already feet per minute, with respect to time, so divided by minute again. And that's where you'll see feet per minute squared. Okay, which again, I think you guys have probably a pretty good grasp on the units from physics. Now, talking about the particle. Let's go ahead and read through these. Make sure we get a little bit of an understanding here. The particle is at rest or changing direction when the velocity is equal to 0. Okay, so a velocity of 0 is going to indicate that the particle is stopped, for lack of better, terms. So it's at rest or changing directions. Changing directions counts as a moment of stoppage because it's stopped, turn around, and go the other direction. Okay? The particle is moving forward or right when the velocity is positive. So that sign, the positive negative sign indicates the direction. And the particle is moving backwards or left when the velocity is negative. Okay, now talking about acceleration, so second derivative. The particle is accelerating when the acceleration is positive, and the particle is decelerating when the acceleration is negative. So that's not talking about forward, backwards, that's talking about whether it's increasing and going faster or decreasing and slowing down. And then the position function just tells us the location of the particle. Okay? So that's all your calculus connections there. Look at example 1, because we have a variety of different things we do with these today. The position of a particle moving along the x-axis at any time t in seconds is given by the equation x of t. Find the position, velocity, and acceleration when t equals 3. Now, also keep in mind, this is on a number line, right? So we're just talking about moving along a number line for this velocity and acceleration. Okay, so find the position, velocity, and acceleration when t equals 3. Well, where would you like to begin? Okay, so we're going to do our derivative works. And meaning, go ahead and take the 3 and... Yep. And since we're finding each of these things at 3, we're going to plug the 3 in to each of those respective equations. So if we go ahead and start with position, that means we're doing x of 3. So negative 3 times 3 squared plus 4 times 3 plus 2. Negative 3 times 3 squared is negative 27 plus 12 plus 2. Negative 13. So what does a position of negative 13 mean? We're going to put it in words. Right. 13 units to the left of 0 or the origin. Okay. So, position when t equals 3 is 13 units to the left of the origin. Okay, ready when you are. Velocity. Means I'm going to be doing x prime of t, right? So you have an option. You can either call it x prime of t or you could call it v of t. What is my derivative? Okay, negative 6t plus 4. And so if we find the velocity when t equals 3, plugging in the 3 means negative 6 times 3 plus 4 is negative 14. What does that negative 14 mean? It's moving, it's a negative 14, right? A negative 14, I guess it didn't, we could talk about a label of, did we give any label? We're given seconds, but we weren't given, so it's negative 14 units per second. If you look up above, notice the particle is moving backward or left when the velocity is negative. So velocity is negative 14, indicating moving left or backward. Okay, so velocity at t equals 3 is, one thing I'm going to say is negative 14 units per second. And you could tack on there moving backward if you wanted to. Okay, and did you guys already do acceleration? Acceleration officially is the derivative of velocity or second derivative of position, right? So x double prime of t or v prime of t or just a of t. What is that derivative? Negative 6. So what is the acceleration when I plug in 3? Negative 6. So My acceleration, what would be the label here? Units per second squared. Acceleration at t equals 3 is, I was going to say 6 units per second squared in a negative x direction. Okay. Looking at example 2, if you guys are ready. The position of a particle moving along the x-axis at any time t is given by the position function. Find the times when the particle is momentarily at rest, times when the particle is moving right, and the times when the particle is moving left. Also find the times when the particle is accelerating or decelerating. Everything all at once, right? Okay. Let's see. We want the times when the particle is momentarily at rest, moving to the right, moving to the left, accelerating, or decelerating. What am I going to have to do to find momentarily at rest, moving to the right, and moving to the left? We're going to have to find the velocity, yes? So to get started here, we need to find the derivative. So if x of t is given as t squared minus 3t plus 2, then x prime of t, or in other words, v of t, is what's my derivative? T minus 3. Okay. How do I find momentarily at rest? Is that what equal to 0? The velocity, right? So momentarily at rest is going to happen when your velocity equals 0. So v of t equals 0. My v of t is 2t minus 3. When does 2t minus 3 equal 0? 3 over 2. So what I can say is at t equals 3 halves, the particle is momentarily, at rest. Okay. They also want to know moving right and moving left. How am I going to find when the particle is moving to the right? Okay, when it has a positive velocity, yes? So that means positive velocity when v of t is greater than 0, yes? Which means positive. So in this case, it's when 2t minus 3 is greater than 0. And you're going to solve that, and we're going to find when t is the greater than 3 halves, we are moving right. And when is the particle moving left? Yeah, when it's less than 0/2, right? So when that velocity, when v of t is less than 0, in other words, negative, right? That's when we will have it moving left. And so in this case, it's 2t minus 3 less than 0. So when t is less than 3/2, this particle is moving left. In other words, before time 1.5. Okay? Putting all three of those things together, does that make sense? Before 1.5, my particle is moving left. At 1.5, my particle momentarily at rest. After 1.5, my particle is moving to the right. So that momentarily at rest was the particle turning around. I think officially we have 2 more questions to answer, don't we? Also find the times when the particle is accelerating or decelerating. Well, in order to find that, we have to do what? Yeah, we have to get the acceleration. So it's the second derivative of the position function, or the first derivative of the velocity, is acceleration. What is my acceleration here? What is the derivative of 2t minus 3? 2. What does that mean? Yeah. No matter what time, my acceleration is always positive. Positive acceleration means that my particle is accelerating. So in this case, it doesn't matter what value I put in. Particle, oh my goodness, particle is always accelerating. Okay, and that's because when the acceleration is greater than 0, it's accelerating. When the acceleration is negative or less than 0, it is decelerating. Decelerating. Wow, I'm having spelling issues today. Okay, so that's some basics. I would assume that relates to your physics, but in terms of calculus. Okay. Let's read the bottom before we flip to the back. Motion due to gravity. An object accelerates towards the center of the Earth at 9.8 meters per second per second. Or in other words, meters per second squared, right? You have definitely seen this number, then, being in physics. Okay, so acceleration caused by gravity. This acceleration is caused by the attraction of the mass of the object to the center of the Earth and is called acceleration due to gravity. Have you worked with it when it's in feet per second? You're only doing meters per second? Okay, because 9.8 is the number you see more often, but I believe it's is it 16 or 32 feet per second squared? My brain all of a sudden, huh? My brain just all of a sudden blanked. Do we talk about on the next page? No, I don't. It might be 32. Yeah. Any other time I could have told you the number, I wouldn't have hesitated, but for whatever reason, Well, and I can't remember when it happens. Maybe it comes up on a test eventually, but just beware that if they give you things in feet versus meters, you have to watch. You know, meters is what we're used to, the 9.8. Occasionally they'll throw in the feet and want you to use 32 instead. So, okay, on the back. Okay. In relation to the Earth's surface, there's a little bit of a diagram there that if you're going up from the Earth, velocity and acceleration are both positive. If something's essentially falling back to the Earth, right, velocity and acceleration are negative. It's all about motion with respect to where the Earth is. Now, our example here, a ball is thrown vertically into the air, so its height in meters at any time t is given in seconds by h of t equals negative 4.9 t squared plus 20t plus 2. And we get 4 parts. So let's start with part A. Find the height of the ball and the velocity of the ball when t equals 1. Okay. Thoughts of where to go? Okay. Okay, the height of the ball when t equals 1, which means we need to find h of 1. H of 1, negative 4.9 times 1 squared plus 20 times 1 plus 2. Negative 4.9 plus 20 plus 2 is what? 17.1, and that would be 17.1 meters. So this is the height. What else does part A want? The velocity when time is 1. So you need to take the derivative. So h prime of t is going to be our velocity, which is we have 9.8 t plus 20. And then we want to find the velocity at 1. So negative 9.8 times 1 plus 20. $10.2. 10.2 what? Meters per second. And this is the velocity at time 1. Okay, part B. At what time t is the ball the greatest distance above ground? When what? When the velocity is 0? Because what's happening at the greatest distance above ground? It's momentarily stopping, right? That's when it turns direction. Because it goes up, it hits its highest height, and it comes back down. So in order to find when is it the greatest distance above the ground, it's when the velocity equals 0. My velocity formula, negative 9.8 t plus 20 equals 0. What does it work out to be? Don't just stop at 0.4 though, not in calculus. 9.8 what?
9.81. That's what we use. It's using physics.
Really?
Yeah. It's not my fault.
Okay, well, beware of that habit because that habit would lose you a point in calculus. I'm just saying because if you're given like a formula like this, like on an AP calculus test, you can't use 9.81.
I was the same thing. I didn't even know I did it.
I wondered why yours was different. I thought you just hit a wrong button. So it's funny that you actually had a reasoning for why your answer is different. This is 2.0408 seconds. Or 2.041, I guess. Okay, so that was when the ball is the greatest distance above ground. So after approximately 2 seconds. Okay, C. How high will the ball go? How do I find how high the ball will go? Okay, so take that time that we just found and plug it into the height equation. So we're doing the height of the original equation at 2.0408. So the negative 4.9 times 2.0408 squared plus 20 times 2.0408 plus 2. Way off the screen here. Did you guys get a number?
22.267.
I like the 22. 4082 is what I have written down on my notes. It's the same as everything else, 3 decimal places.
So always go to the first 5 decimal places.
Oh, are you talking about like if you're working within a problem?
Oh, no. Like, I guess if you ran something inside the problem, it's probably more yourself a little bit. So,
Oh, I see what you're saying. Yeah.
like,
And this is where, in all honesty, in this case, if you write this answer down here for part B, then they're going to expect for part C that you use that exact answer. That's what they're going to base it off of. Don't, because my guess would be if you miss something here, but you use that time here, and you do the right thing here, they'll give you the point. Does that make sense?
yeah, I hear what you're saying.
Yeah. Okay, this was a height, so I'm going to label with meters. Okay, and part D. I never even read it. What is the greatest acceleration of the ball? Well, let's start by finding the acceleration, right? Have we found the acceleration yet? Officially, no. So if you find h double prime of t, which is v single prime, that will be acceleration. What is that derivative? Negative 9.8. So when it says what is the greatest acceleration of the ball, well, the acceleration is constant. It's always the negative 9.8 meters per second squared. So acceleration is constant at negative 9.8 meters per second squared. Okay. That wasn't crazy difficult physics, was it?